I just realized my audio was off. Hopefully you guys can hear me now. As I was saying, which you couldn't hear, delta H is Q divided by moles, Q equal MC delta T, moles and mass over MR. In Q equal MC delta T, M is the mass of water, moles is mass over MR, mass is the mass of the fuel. Now all I have to do is put them together, because delta H is enthalpy of combustion in this case. So it's going to be Q MC delta T, the mass of water, W, C, specific heat capacity, delta T, divided by number of moles. But it doesn't have that. And moles is mass over MR, mass for MR. So if we times by MR, we'll have the MR here and dividing by the mass. And the mass of what? What is it the mass of? It's the mass of the fuel. So it should be B on the bottom. So it's it is going to be W C delta T MR divided by B. Also, because all of these are negative, it's also going to be negative as well. Because temperature rise, the temperatures are increasing, it's going to be negative. So it's going to be minus WC delta T MR. And therefore the answer is A. All they've done is just put the C in front, minus CW delta T MR divided by B. Question 5. What is the amount of heat energy absorbed by the water? Q equals MC delta T. M is the mass of water. Mass of water. The reason I'm like going through these tiny details, and even though it's just a 1 marker, is that when you go to like these 5 markers, which they do ask about these kind of questions, 5 markers, I think I've seen on A-level papers as well, not just AS. 5, 6 markers, most I've seen is probably 5. And what they give you is they'll give you 2 masses, and you have to identify which mass you're using for which equation. And in this case, for Q equals MC delta T, mass of water, moles is mass over MR, is the mass of the fuel / alcohol, whatever else you're using. And you need to know that, because if you use wrong values for an equation, you're not going to get the right answer, and therefore you're going to lose loads of marks. So in this case, it's going to be Q equals MC temperature rise. Why? That's literally going to be it. So the answer is going to be A. And I feel like students would not go for C or D. They'd be confused between A and B, because yeah, that's MCY, but also that's in degrees Celsius. Surely you want it in Kelvin, because that's in Kelvin. But remember, with temperature rise, because it's temperature rise, don't convert to Kelvin. So the answer is A. And then question 6, definitely a very hard question. The heat released was the heat released by each molecule in joules when ethanol undergoes complete combustion. So heat released. So I'm going to use delta H equals Q divided by number of moles. So Q equals 29,800. Moles equals mass over MR. So if I do that, 29,800 divided by 1 over 46, and then I want released by each molecule, and then, but actually no, heat released by each molecule. I've got the moles, 29,800 divided by 1 divided by 46. Each molecule, do I divide by Avogadro's constant or times by 6.022 10 by 10 to the power 23? Maybe I'm just using the wrong. wrong equation. The heat released when 1 gram of ethanol with a MR46 undergoes complete combustion is 29,800 joules. What is the heat released by each molecule in joules when ethanol undergoes complete combustion? Avogadro's constant is 6.022 times by 10 to the power 23 mole to the power minus 1. I don't think I'm using the correct equation. Yeah, because that's heat release. It's not asking for enthalpy of combustion, is it? So we calculate the number of moles. That's easy. Yeah, definitely I'm doing something wrong. Let me have a recap. So I've got this in joules, that's correct. I've got the moles, which obviously we're going to have to work out because why else would it give us the mass and then also the MR. But let me just work out the moles separately. 1 divided by 46. 0.0217. Now I want the heat released by each molecule. So firstly, in order to find out the number of molecules, oh yeah, if I want to find out the number of molecules, all I have to do first is moles times by L, which is 6.022 times by 10 to the power 23. So all I'm doing is my answer 0.0217 moles times by 6.022 times by 10 to the power 23. That will give me 1.31 times by 10 to the power 22. That's not any of these. And then what I need to do, that's the number of molecules, right? Moles times by Avogadro's constant. Then what I need to do is to calculate the heat released by each molecule. Oh, I'll find out the number of molecules, and therefore to find out the heat released by each molecule, I'm just doing the total heat, 29,800 divided by number of molecules. Okay. Well, at least I learned how to do this now. Yeah, that makes complete sense. 800 divided by my answer, 2.28 times by 10 to the power minus 18, and it's obviously in joules because I converted it from kilojoules to joules in the beginning anyway, so that's fine. So the answer is A. Calculate number of molecules and do the total heat energy divided by number of molecules to find out heat released by each molecule, and that's the end of the multiple choice questions.